all use math every day, to predict weather, to tell time, to handle money. Math is more than formulas and equations. It's logic. Math is more than formulas and equations. It's rationality. It's using your mind to solve the biggest mysteries we know.
All right, well, welcome back, Algebra 1 students. We are continuing on in our polynomial chapter here, chapter 7 of the Big Ideas curriculum, with now special products. Product, again, is another way of saying multiplication. We are multiplying two binomials, as you can even see here in the essential question. There's two binomials again. We've done those in the last section, in section 7.2. So what we're going to be looking at is some special ones, and it says use the square of a binomial pattern. Look at that. We'll use the sum and difference pattern, and then we'll actually use these special product patterns to solve some real life problems even. All right, so before we get into these special products, let's go ahead and take a look at our joke of the day, or actually our cartoon of the day, Far Side cartoon. Here we go. So little league out on the baseball field. Take the field. And remember, your parents are counting on you to achieve their unfulfilled dreams of sports glory. Isn't that the truth sometimes? All right, well, let's move into our first part of this. It's a binomial pattern, the square of a binomial pattern. So what we're going to see is we're going to see a binomial, and we're going to see the exponent of 2 on the outside, so we call it a binomial squared. And we can then turn it into a trinomial. And this kind of gives you a little bit of a picture, a visual of kind of what we're doing here. Remember how we did that one part before in the last section where we made it into a kind of a table. And that was one method and one strategy to be able to multiply binomials. So they basically did that here too, but both of them are A and a B. So you have an A plus B on the top, you have an A plus B on the side. And so if we multiply for the first box, A times A is A squared. This box here is A times the B. This box is also A times the B. And then this one over here is the B times the B for B squared. So the AB and AB are like terms that we would combine together to give us 2AB. And so that's essentially what we're doing, is we can use this box pattern to do it again if we want to. But the pattern is basically the first one, so you're getting a trinomial. The first one is you're going to multiply A times itself. The last one, you're going to multiply the second one, B times itself. And for the middle term between those two, you're going to multiply these two times each other and multiply by 2. So 2 times A times B for that middle one. So that's kind of the pattern that we can see. You can do the same thing with a minus sign. The only difference, if it's a minus, this sign here would be minus instead of plus. You can see everything else is the same. All right, so here's the core concept. So the same idea, but you can see a couple examples shown here to you. X plus 5. So if we say, okay, I'm going to square 5 first, that's x squared. And then 5 times 5 for the last one is 25. And then these two times each other is 5x times a 2 is 10x for the middle one. So there's that. And they can do the same thing on this one. Even though there's a minus, we're going to multiply 2x times itself for the first one, which is going to be 4x squared. 2x times 2x is 4x squared. And then negative 3 times negative 3 is positive 9 for the last one. And then these two times each other, which would be 2x times negative 3, it's a negative 6x. Then times 2 is going to give us a negative 12x for the middle. So that's kind of the pattern that we can go off of just to be able to do this, the square of a binomial pattern. Let's go ahead and look at our extra practice now. So on page 217 there in your notes, let's take a look at, I'll show you 1, 4, and 7, and you can do these other ones on your own. So number 1, we have A plus 3 squared. So we're going to start with the first one. We're going to multiply the first one times itself. So A times A is going to be A squared for the first term. We can get the second term by doing A times 3 times 2, or 2. You can start with the 2 first so you don't forget the 2. 2 times A times 3. So you're going to multiply 2, because there's 2 binomials. That's why the square is up there. 2 times A times 3 is a 6A. That's positive. And then we're going to multiply the 3 times itself. 3 times 3 is 9 for the last term. And there you go. There's your square of a binomial. Now, if all else fails, you could always revert back to multiplying the two binomials like we did in the last lesson. You just see there's two of these, a plus 3, and you could write out another a plus 3 and multiply them with the method that you like from last time. You can use the FOIL method, in fact, or the double distributive property method, which is horizontal form. So you could still do that. You could still revert back to that, but now the special one here can kind of have a pattern to be able to get to it. You can kind of get to it a little bit quicker, I think, if you use the pattern. All right, for number 4, same pattern here. We're going to multiply the first one, the negative 2x times itself. So negative 2x times negative 2x is positive 4x squared. The middle one is going to be starting with 2 times these two times each other. So 2 times the negative 2x times the positive 1 is going to give us a negative 4x for the middle one. And then 1 times itself, 1 times 1 is still 1, so positive 1 in the back. And then for number 7, we start with 3x. We're going to multiply that by itself. So 3x times 3x is a 9x squared for the first one. And then 2 times these two times each other. So 2 times 3x times 2y, well, that's going to be 12xy. So 2 times 3 is 6, times 2 more is 12. And then you have an x and a y on that one. And then 2y times 2y, 2y times itself for the last one. That's going to give us 4y squared. It is positive, so plus 4y squared. All right, so I'm going to give you a chance here to do the other 6 here, 2, 3, 5, 6, 8, and 9. So do all 6 of those and get your trinomials. They should all be trinomials here. So get your trinomials, and once you've finished all 6 of these, then just play the video and check your answers. Okay, so you should have paused the video and now you're just checking your answers for these 6 problems here. So let's see how you did. So for number 2, the one with the variable b, we're going to get b squared minus 4b plus 4. That's your trinomial on that one. You can see what we multiplied here. For number 3, c plus 4 squared, we're going to get c squared plus 8c plus 16. Again, if you miss anything, just maybe pause it and see maybe what you did wrong here, as you can see what I'm multiplying here for each term. And then for number 5, the 3x minus 2 squared, so we're going to get 9x squared for the first one, and then minus 12x for the middle, and then positive 4 for the last one. Number 6, negative 4p minus 3 squared, so it's going to be 16p squared for the first term, positive 24p for the second one, and then positive 9 for your last one. Make sure you understand the signs here, so an easy mistake might be made with getting a sign wrong. Perhaps you might have got a sign wrong. Just see on each one of these we're multiplying negative times negative to get a positive here. There's 2 negatives in this one, making that one positive. Negative times negative here, making that positive. Number 8, 2a minus 3b squared. It's going to give us a 4a squared, then a minus 12ab, then a plus 9b squared. So this one was kind of like number 7, where we had both a and b at a variable on each term there on that binomial. And then for number 9, negative 4c squared plus 5d. So again, 2 variables in this one. First term is going to be 16c squared. Middle one is negative 40cd, and then positive 25d squared. So there you go. So on the first one, you're going to get negative times negative, making that term positive. For the middle one, there's only one negative, so that leaves that as a negative term there. There's only one negative. And then they're both positive on the 5d's there, making that positive. All right, let's move forward to our next part. So the next part is a different pattern. We're going to look at the sum and difference pattern. So a sum and difference pattern is that shows you 2 binomials, and they're exactly the same binomial. Like here's an example of one, of x plus 2, x minus 2. It is almost exactly the same, except one's a plus and one's a minus. So when you actually do this with either the FOIL method or any of the other methods we did on the last lesson, and you start to do this out and you get 4 terms, you're going to notice you're going to cancel the 2 middle terms. Negative 2x, positive 2x that we would combine actually cancel out, so there is no middle term now. You're just going to have x squared and the minus 4 in your answer. So what we would call that is a difference of 2 squares. So a sum and a difference pattern will multiply and give you a difference of 2 squares. That's what we end up getting. The actual pattern that we just did, the pattern on this last one here, which was a binomial squared pattern, this is going to give us what we call a trinomial square. So these would always multiply to give us what we call a trinomial square. That's going to come in, and we're going to see that again later on as we try to go from here back into this pattern. So we're going to go back and forth between these two. One's called multiplying, the other one's called factoring, and we're going to get to factoring here in a few lessons from now. So the core concept, you can see your core concept down below here. I wrote a couple things in here. First of all, you can see that the signs are the same here between A and B. So A and B, they're both positive, but on this one, they're different. A is positive, B is negative. So that definitely means you have a sum and a difference. So basically your A term is, you could also think of it this way, your A terms, the first ones, they're the same. A's are both positive, but B's are different signs, positive B, negative B. So there's another way you can identify a sum and a difference. Okay, so here's that one. They're the same signs, and these ones are different signs, or X's are the same sign, the 3's are different signs. So it definitely tells you that they sum in a difference pattern. Because the first thing you need to do is identify that you have a sum and a difference pattern. All right, let's take a look at our extra practice now on page 217, 10 to 12, and then starting on 218 we have some more. So let's start with number 10. So let's just do these three here. Let's see how we can do here. Starting with number 10, this again, a sum and a difference is the pattern. These are all going to be sums and differences, so we need to identify the fact that they are. So we had x minus 3, x plus 3. I think we just saw one like that in the core concept. But for our first part, we could think about doing it with FOIL. I'm just going to show you, if we did this one with FOIL, here's what we would look and see. So the first terms would be x times x, that's an x squared. The outside and the inside terms, right here, outside would be x times 3, so that's going to give you positive 3x. The inside is as x times negative 3, which is going to give you negative 3x, and those will cancel out when you want to combine them. So you're not going to have your outside and inside. Your last terms would be the negative 3 and the positive 3, and that's going to be negative 9. So our answer for this one is going to be your first term, which is x squared, and your last term, which is the minus 9. That's our answer, and that we would call that a difference of two squares, binomial. So when you have a sum and a difference, you can really almost just remember to only have to do the first and the last to be able to do this pattern. You just need to multiply first and last from FOIL. Let's take a look at, actually go ahead and try, I'm going to have you try number 11 and number 12 since we're on this page of 217 before we go over to 218. So go ahead and pause the video, try 11 and 12, and you can just know to multiply first and last because this is a sum and this is a difference, sum and difference on both of them. So if you just remember to now just multiply first and last, that will give you your answer. So pause the video, do 11 and 12, and then play it to check your answers for those two. Alright, so you should be checking now number 11 and 12. So for 11, we should get q squared minus 25. So your first terms is q times q. The last one's is 5 times a negative 5 for negative 25. For number 12, we should be getting t squared minus 121 because your first terms is t times t. Your last one, negative 11 times 11, negative 121. So again, your outside insides, you can see that they would cancel each other out because like on 11 here, you're going to get outside negative 5q, inside positive 5q. Those are opposite terms and they would cancel each other out. Number 13, so now on the top of 218 here in our notes, you can see here these are different, so they're definitely sums and differences. That's what I'm trying to show you here. We have different signs. The 5a's are the same, but the negative one and positive one are different. Definitely a sum and a difference. So for this one, if we do the first terms, 5a times 5a, we're going to get 25a squared for the first part. Your o and your I, that would cancel out. You could see that. You would get 5a for the outside, negative 5a for the inside. They're opposites. So now we would just do the negative 1 times the positive 1, and that's for our last one is negative 1. So 25a squared minus 1 is our answer on that one. Let's take a look at number 16. Again, this one you have the negative m, those are the same, but the 2n and the negative 2n are different, definitely identifying that as a sum and a difference. So when we do our first terms, that's the negative m times negative m, that's going to give you a positive m squared, because negative times negative is positive. And then 2n times a negative 2n for your last one. Remember, o and I will cancel each other out, so we don't need those two. So 2n times negative 2n is a negative 4n squared. There's our answer there. Again, it's going to be a difference of two squares answer. And I'm also going to do number 18, and I'll have you do these three on your own. This one's a little bit different because we see the different ones are the first ones. 6a, negative 6a are different, but the b ones here, positive 1/2 b, positive 1/2 b, they're the same. So it still needs to identify that as a sum and a difference. This one would be, they're both the same sign. This one, they're different signs, but everything else is the same. The numbers are all the same. The letters are the same. So your first ones here would be 6a times negative 6a. So for negative 36a, that's our first part of the answer. And the last ones is the 1/2 b, 1/2 b. So multiplying those together would give you positive 1/4 b squared. B times b is b squared, and the 1/2 times a 1/2 is a 1/4. Remember, multiply the top numbers, multiply the bottom numbers. All right, so go ahead and pause your video now and just try the other three on this paper, or on this page 218, 14, 15, and 17, and then check your answers by playing the video. Okay, so for 14 and 15, you do have some fractions on here, so those might have given you a little bit of trouble. They shouldn't too much, because multiplying fractions is not too hard. So your first ones is going to be the 1/4 b's. 1/4 b times 1/4 b. 1 times 1 is 1 on top, 4 times 4 is 16 on the bottom, and it's got a b squared. The last one is 1 times a negative 1, so it's just negative 1. There's your answer. For 15, your first part is going to be the 1/2 c's. So that should be pretty easy. A 1/4 c squared you're getting from multiplying that times itself. And then the last one's the 1/3 times a negative 1/3. So positive times negative is always going to be negative here. And then 1 times 1 is 1. 3 times 3 is 9. So it's a 1/9. And then for number 17, on this one we're going to do our first terms with those j's. Negative 3j times negative 3j is a positive 9j squared. And then for the last ones, negative 2k times positive 2k, so that's a negative, and it's going to get 4k squared for that. All right, so hopefully you're able to see you got those answers correct. If you missed something, just maybe pause it and see if you can figure out maybe where you might have went wrong. Maybe it was just a sign. Maybe you multiplied something incorrectly. All right, let's move on to our next part, which is just the joke of the day. Here we go. What is brown and sticky? What is brown and sticky? A stick! Ha ha! Oh, that's great. Never would have thought of that. A stick, of course. All right. Well, enough humor for us right now. Let's keep going. All right, we're going to see now, we're going to use the special products pattern to find a kind of just a product of numbers. So this is kind of something 26 times 34. You could multiply that together on a calculator. You could do 26 times 34 long way. So obviously if you use a calculator, that kind of, is cheating in some sense. But if you were to just do this long, like 26 times 34 longhand, that could take a little bit of time. And I'm going to show you how you can maybe do this maybe a little bit faster using our special products here. So I'll show it right here. So what we're going to see is that since 26 and 34 are pretty close to the same number 30, 26 is 30 minus a 4, and 34 is 30 plus a 4. Now that gives us, and they're the same distance away, in fact. So they're the same distance away, not just both pretty close, they're the same exact distance from the same number 30. That's what we want to do. Break it apart there to do that. And so then we can just use our special products and just do the outsides and the first and the last, really. 30 times 30, 4 times 4. And so that's what we're doing. Getting 900 now minus 16, and that's easily done pretty much in our head. 884 is our answer. You can check that on a calculator. All right, let's try a couple here. 19 to 24. In fact, I'll try 21 first, and it's got the fractions. So 19 and 3/5 times 20 and 2/5. They are both the same distance away from 20. They're 2/5 away. So it's 20 minus 2/5 for this one, and it's 20 plus 2/5 for the other one. So we're going to do 20 times 20 first terms. So the first one is 20 times 20. The last one is the negative 2/5 times positive 2/5. So it's going to end up giving us 400 minus, when we multiply, 2 times 2 is 4, 5 times 5 is 25. So 400 minus 4 over 25. So that's going to basically make this into 399, and there's 21 left over. So that's 21/25. 399 and 21/25. So I did kind of the hard one for you on that one. Let me go ahead and do number 23. Actually, let's do this. I'll have you try 19 and 20 first, and then we'll come down and do these ones that are a little bit different. So pause the video, do 19 and 20, see if you can do this with the same pattern. 19, these two numbers are the same distance away from 20. These two are the same distance away from 50. So try 19 and 20 using this pattern and see if you can multiply them without a calculator and without doing it kind of long version. So pause the video and then check your answers for 19 and 20. Alright, so you're checking your answer here for 19. We would say that these are 2 away. They're both 2 away. 20 minus 2 is 18. 20 plus 2 is 22. So 20 times 20 is 400. So that's going to give us 400 there for the first terms. 2 times 2, that's going to be positive times negative, so it's negative 4. So 400 minus 4 is just going to be 396. So you should have got 396 for that one. Number 20 is going to be, they're both 1 away from 50. 50 minus 1 is 49. 50 plus 1 is 51. So if I multiply 50 times 50, that's going to be 2,500. Multiply 1 times 1, that's just going to be minus 1. So if I take 1 away, that's going to be 2499. So here's what you could do. You can take these numbers to your friend, something like this, or some way you can do this, similar numbers, and see, okay, you can challenge them to how fast can you multiply those numbers. And they'll probably do it the long way, and you can do it this kind of faster way and get to the answer a lot faster and show how much better at math you are. All right, so for 22, 23, here's where we have a number squared. So I'm going to do this one, 23. We're going to see that this here, we could break this apart to 20 plus 0.7. So I can say 20 plus 0.7 is a 20.7. And so we're going to square that, and so we're going to use that pattern now. So we're going to do 20 times 20, and then 2 times these two times each other, okay, 20 times the 0.7, and then 0.7 times 0.7 here. And so 20 times 20 is 400 again. If I do this, that's going to be like basically 2 times 2 is 4. 4 times 7 is going to be 28. With a 0 is 280, but we have a decimal to put in, so it's only 28 there. And then these two is going to be 7 times 7 is 49, but there's 2 decimal points to put in, so 0.49. So 400 plus 28 plus a 0.49 is 428.49. There you go. All right, so go ahead and try. Same thing for 22 and 24. This is going to be like 30 plus 1. This could be 100 plus 9. That would be easy to do. So try the same thing for 22 and 24, and then play it to check your answer. All right, so you should be checking your answer for 22. 30 plus 1, so we're going to do 30 times 30. 2 times these two times each other, 30 times a 1, and then 1 times 1 in the back. So that's going to give us 900, and this is going to be 60, and then a 1. So it's just 961 for that one. And then this one's 100 plus 9. Oops. 100 plus 9. So we're going to do 100 times 100. 2 times 100 times the 9. And then 9 times 9. And so it's going to give us 10,000 for 100 times 100. This is going to be 2 times 9 is 18 times 100 is 1,800. And this is 81. So you're going to just put that in as 1,108.81. And there you go. So again, you can do this with your friends and just kind of impress them with your math skills. All right, so we have one more problem to look at. Number 25, it's going to ask us here, find k, so that this k and then x squared minus 2x plus 9 is the square of a binomial. So this would be like a trinomial square that we talked about in the first part. It's the square of a binomial. It's like the answer we would get from a binomial. So again, we need to remember this. So the square of a binomial is like a plus b squared, and we're going to do this, a times a, 2 times a and b for the middle one, and then b times b for the last one, would give us this. Well, we're trying to now find what number should be in front of this like x squared here. What number should that be? So what we know is that from the 9, like the b squared, that's going to be that to b times b. So what times itself is 9? 3 times 3. So that's got to be 3 times 3, and it's got to be negative 3 because this is a negative here in front of 12. So negative 3 times negative 3 would be positive 9. And then the 12 here would be the 2, and then the negative 3 from this one, and then it's going to be half of this k. Whatever this k is, it's got to be half of it to be able to figure out what we would put in here. And then for this part here, you could see it's going to be half of k times itself. That's what we're looking for. So again, we're trying to figure out what k is. So in this one, if we say, okay, if we say 2x, if we say this part here is 2, because what would make 12? 2 times negative 3 is negative 6. So this would have to be 2x in order for this to be negative 12. 2 times negative 3 would give me my 12. So that's got to be a 2x there. So this 2 is got to be what k over 2 equals. K over 2 equals 2. And so if we solve for k by multiplying both sides by 2, that's got to be 4. 4 over 2 equals 2. So k has to be 4. So that's one way you can kind of see it. Here's another way that you can see it as well. I wrote it down like this. If we were to say 2x minus 3 squared, and here's kind of how we're checking it. If we say, okay, it's 2x, because remember we got to put 2 here, okay, because this has to be 2. We can see that if I then did it with the pattern, 2x times 2x is 4x squared. That would have to be my k. K has got to be 4. Okay, so that's what our k is. We were able to figure that out, kind of working our way backwards in this pattern to figure this out. All right, so that was the last one on this special products lesson, and we'll see you again on 7.4. Have a great rest of your day.